at Virgil Systems. Before I dive right in, I want to tell you that the flow of this presentation has changed on the fly after hearing Michael wanting to see actual real live demos of using blockchain and distributed ledger technologies in real life in a way that isn't cryptocurrency, as wonderful as currencies are. Then we've decided to switch things up a bit. And so at the end of this, we're going to take a moment to actually show you our technology in action. And who are we? Well, as I mentioned, I'm Chief Operating Officer. I've been in cybersecurity and entrepreneurship for many years and hold an MBA in entrepreneurial finance and have worked in at least 5 continents doing this kind of thing. But the origin of the idea really comes from Aaron Majumdar, our CEO and our co-founder and partner. He's an expert in cryptologics, holds patents in cryptography and artificial intelligence and quantum computing. And he spent a good part of his career working with large enterprises on their cyber defense strategies. His prior venture served the Pentagon and Fortune 100 companies as its core customer base. And so he's really intimately aware of the security needs and vulnerabilities in those kinds of networks. Wendy Joy leads our engineering efforts at the very top level, and she spent over 20 years building large systems for the US Navy. On the line with me, I think she's on the line as well. On the line also is Gove, who's a phenomenal coder who leads all of our development and has an expertise in distributed computing. Herman, who is also joining us, has a very incisive analytical legal mind and is able to manage very complex projects. So we've got a great team. Really interesting to point out also is Dr. Barney Pell, who's a key advisor. He spent a number of years working at NASA designing deep space communications and was also the founder of PowerSet, which was acquired by Microsoft and ultimately became Cortana and Bing. So, we've got a fully loaded team. We're growing rapidly. One of the asks we'll give at the end is if you know any great developers and engineers, please have them virgilsystems.com/careers. We are growing rapidly. Now, the internet as it's structured was built and designed in the late 70s, 1970s, 1980s of last century, and it has largely remained unchanged. There's a lot more bandwidth, there's a lot more content creation, a lot more data consumption, and that's grown exponentially. And it's reached a point now where data is the most important, crucial commodity in the world. Trillions of dollars is exchanged internationally in financial transactions, live hang in the balance, in the operating room, in the streets at home and abroad as our service members work to keep us safe. Artificial intelligence agents make decisions using data that allows our world to move around. And so in this context, we really need to trust the data that comes over our network. And we can't, because we know that attackers are in there that can deny our access to information, that deceive us with fake data, hashtag fake news, create delays in the data, degrade it, can destroy the data. And on top of that, as we move towards 4G, 5G infrastructure, we have to deal with miniaturization of electronics, and those are susceptible to data faults as well. And so long story short, the problem that we're trying to solve at Virgil Systems and that we are solving is one of allowing everybody in the world to communicate with each other with trust. And we feel like it's one of the most compelling problems in the world to work on. Now, this is really compounded for telecommunications networks operators because they're trying to make investments into their network on a continual basis. They have increasing regulatory and operational costs, and there's a decreasing ability to capture value. And so the technology that we put into place really provides them with an opportunity to protect their investments, to prevent downtime, and increase revenue. So we'll take a moment to dive into how we do that. With our solution, we're able to allow them to open up new lines of business by offering end-to-end data management, content delivery mechanisms, helping them support mission critical applications, to provide secure data storage as an alternative to cloud storage, to provide governance over data. Meanwhile, there are significant advantages that are put into place on the infrastructure side, where we provide an anti-fragile solution. And this is kind of where we sit. You know, there's an entire network of communications that happen in the world of finance, defense, energy, transportation, and healthcare. And we sit below those applications and combine unique and improved error correction codes with an intelligent alternative routing system over distributed ledger technologies that can assure the integrity of data, even if there are attackers or interference in the network. So we've created an adaptable and programmable digital infrastructure solution that provides a value-added storage and communication alternative that can deliver assured data integrity and availability, that can protect network investments, and detect stealthy attackers within the network. So let's take a moment to see how this works. Should be able to hear this all right.
Alice wants to send information to Bob with data integrity. Alice selects the data, which is fragmented into shards, and each shard is transformed into a tokenized hologram. Here's how it works. First, the data is sharded and hashed, and each shard is combined with its hash. Additional data is mixed in, creating a data hologram. The holograms are compressed and secured against eavesdropping. The tokenized holograms are ready to send. All of this happens nearly instantly. Alice's node searches the network for available hosts and creates a smart contract consisting of the order of randomly distributed tokenized holograms. The cryptographic receipt is generated, serving as a map for Bob to find and reassemble the tokenized holograms. This receipt is transmitted to Bob in a specially secured channel. Data integrity and availability is assured, even if up to 80% of the data is destroyed or delayed in transmission. Bob's node uses the receipt to gather and reassemble the scattered tokenized holograms. An alert is issued if there is interference with the data in transit. Virgil Systems, connected with trust.
So I think the one thing that I want to point out there is the key figure of 80%. Essentially, if our data gets degraded, if your data gets degraded, if 80% of the network goes down, if 80% of the data is attacked, we're actually not doing an integrity check, but actually able to restore the integrity and recreate the data from the 20% that remains. So really crucial mission critical applications can depend on this kind of technology. We're a graduate of the Creative Destruction Lab out of Toronto. We have a massive contract underway with a giant customer that has a critical and urgent need. We're growing our pipeline and are eager to talk to additional customers, especially within the telecommunications and large enterprise space. And we are also a partner in the Encore 5G program in Ontario and Quebec, working with the 5G network test bed to see how we can enhance the resilience and integrity and even building in anti-fragility into 5G networks. So our ask for you today, before we dive into what I hope will be a demo, I'm going to try to pull that up on the fly, is we'd love to talk to enterprise CIOs. We're interested in speaking to telecommunications operators, particularly those groups within them who are in the line of business dealing with government and large enterprises. And of course, if you think you have a technology or a service that complements ours, we'd be keen to talk to you about that. And while I'm pulling up the demo, I'm happy to address any questions that you might have.
Alrighty, so feel free to put questions in the Q&A, or